Hi guys, in this video I will show you how to create a modular window using Grasshopper, and in this script we will create different kinds of windows that are facing in different orientation. So some windows are facing straight, some are facing upwards, some are tilting to the left. We can customize all the angles, the protrusion length, and also the rotation in this script. So this is quite a common architectural feature nowadays. It's like a modern modular window inspired by the Capsule Hotel and also by Zaha Hadid. So I think we can create this script from scratch. I'll go into File, New Document. In this Rhino file, I already have the surface in this file. I'll just command show to show the surface. So the first step we want to do is that we want to assign some squares on these boxes so we can divide the surface. So we're going to create a construct domain first. In this construct domain, we're going to create some numbers. So this creates the number of rows and number of columns on the surface. Before that, we will need to create a B-wrap as well, so that we can link this B-wrap from Rhino into Grasshopper. And then the command here is also called isotrim. Isotrim is to divide the surface using a domain. So I'll connect the B-wrap onto the surface, and then I will do my domain start and domain end. Think of domain like a range. I'll connect it here. So this doesn't work. I think, sorry, the script here is called divide domain, my bad. So the domain is from the B-wrap. You want to connect the B-wrap into the domain, and the U count and V count you want to create, let's do 5 and 5 for now, so we can get 25 different surface. And the segments we will connect into the isotrim domain. So I'll just hide the B-wrap for now and hide this in Rhino as well. So you can see right now we have 25 equal surface, and if I reduce this number lower, I'm gonna get lesser columns. So I'll keep it 5 and 5 for now. As you can see in the original script, there are some windows that are joined together. So there were 3 boxes here, but we have merged into one single piece of window. So think of it like an apartment. Some apartment can have a larger window, some are smaller. So we want to start assigning all these merging windows together. So coming back here again, I'll just do a point list, and then I'll do an area. So what this does is that I can start visualizing the item or the number of surface. So it starts from 0, 1, 2, 3, 4, so on and so forth. So I can start to see every single surface and its associated number. So the reason why we're doing this is because it is helpful to identify which surface do you want to join, so you can pick out the numbers. So for example, we will need to do a B-wrap join, so we can join up the surface. I'll command panel. So for example, I want to join 13, 18, 33. So I'll just type in panel. So I created a panel script. I'll put in 13, 18, and 23 into a panel. And because this is just a panel, you need, in order to make this into a data so that Grasshopper can use, you have to right click and multi-line data. So this will create an information based data that can be used in Grasshopper. So we have to go into multi-line data. So I will go into list item. List item is to select the surface from the list, and the index will be this data here. So you can see list item will select these 3 surface from the isotrim surface, from the 25 surface. So once I selected these three surfaces, I can do a B-wrap join. So it joins them into one B-wrap. But the problem here is that once it's being joined, you can see that there's still two lines here. It's still recognizing this as three separate surfaces. If you leave it like this, it's gonna be a problem because Grasshopper will still think that this is three surfaces. So you will need to do a merge face component so that you merge it into one single surface here. So it's just one. Okay, so and then let's do a couple more. Let's do 2 in total. I will merge 6 and 11. So come down here. So what I did here was I copy this entire thing down and I do 6 space 11. Press enter. Sorry, press backspace and I click outside here. So this would merge 6 and 11 into a separate surface. So that is good. So now the next step here is to combine this two joint surface and merge it with the overall surface here all together. But the problem is that the original surface still have 25 surface, and if we add this two additional surface, we're gonna have 27 surface. So which is a problem. So we need to somehow from the 25 surface take out 3 surface and take out 2 surface and stitch it back with this 2 larger surface. So we need to do a cull index. A cull index is to remove the surface, remove all the surface that has been joined from the 25 surface. So I will go into list. There will be my list to cull. My index. So my index will be the combination of all this surface that has been joined. So I'll do a merge. I will do a merge here and then do my index. So as you can see now, whatever is green here, it's the other surface that hasn't been joined together. It's the original surface that we want to keep. So all we need to do is to merge the green surface here and merge it with these two surfaces here that are green. So you have to merge it. Data 1, data 2, and data 3 overall. So we should have 22 surfaces in total, which sounds about right. So this is the result here. Okay, and looks pretty good. What I'll do is that I'll probably do one more. I'll combine, let's say 2 and 7. I'll do 2 and 7. Press OK. And then in this B wrap, I'm gonna combine this to cull it as well, so I can remove it from the original 25 surface, and I will add this in. So that looks really good. I'm happy with that. So because this original point list, it visualizes the points based on the 25 surface. But now, because I've done my merging, I've done my culling, I've already joined out some surface, so I need to redo my point list. And this is my new number here. Okay, so my 1, 2, there's two 2s here. So it's probably because my listing is still, some of it are still grafted. So we have to just flatten this down. So everything will be organized in sequence. 0, 1, 2, 3. So this is a good starting point now. So the next step here is to start creating the windows, the modular windows. So we will need to deconstruct B-wrap. Create the B-wrap here, deconstruct it, and I'll hide this. So once we deconstruct it, notice that we have faces, edges, and vertices. So deconstruct, it breaks down the surface and it generates 3 different data, which is the face, the edge, and the vertices that we can use. So I'm going to join up all these edges. The reason why I need to do this is because the edges comes in broken curve. So 0, 1, 2, 3 is actually the 4 sides of each square. It comes in as 4 different curve that is like exploded. So we need to join it back again using join curve. Join it back again, and the reason why we want to join is because we want to fillet. We want to do a fillet to fillet off the edges. Let's say the radius I want to do somewhere between 0 ... to 200, for example, and I'll just do somewhere 1. I'll just increase the range to 500. Press OK. So somewhere here. So I'll hide all this. That looks really good. So the next step here is to start designating a set of patterns. So some windows are gonna look up, some windows are gonna look down, left and right. So probably let's just do a scribble, scribble, and let's start some windows that will be that was looking to the left. Let's do a tricky one. Let's start a window that's going to the left. I will do a panel. So let's start assigning some windows that will look to the left. So I'll do probably window 14. I'm just choosing this randomly. There's no logic. Window 16 and window 8, for example. Again, we have the multi-line data so that Grasshopper can use this information. The first step is to list item, so we can select all this surface based on this index. The original list to choose from would be this curve. Okay, so now let's see. Yeah, so the reason why it's not selecting is because everything is all grafted here, which is fine. So we will just need to flatten this down. Okay, and that will work. Okay, so this surfaces 16, 8 and 14 has been selected, and the evaluate surface, this will make sense as you watch along this video until we complete the full script, so that we can generate a window that faces to the left. So what I'll do here is that evaluate surface. Okay, I'll just do a B wrap and evaluate the surface. So the reason why we want to evaluate the surface is because we want to create a slider. We want to create a slider that we can change. So as you notice here, we can change the slider so that we can create the direction of the window by using this slider. So currently it's just a point, and then we can do a move to script where we can say that the geometry we want to move will be this geometry, these 3 surface. We want to move from A, which is from the center. If I type in area, this will give me the center of the original surface. Centroid is the center, and I'll move it to the slider that I've been playing around with it. into my point B. Okay, so as you can see, if I move it around, it's gonna move the box, the filleted box. So I'm gonna do a scale NU so I can control how much I want to scale in X, Y, and Z. So I'll connect to the geometry here. The plane will be the B-wrap. B-wrap can be the plane itself. And then scale X will be obviously 1 because scale X is actually perpendicular to the surface. You can't scale according to that direction. I'll probably do 0 to 1 because 1 is the maximum. Sorry, I'll do it here. And then I'll change this into a floating number so that I can create the decimal. Okay, that's just scaling from the top, which is not what I want. I think the plane, we can do it from the center. Okay. And then scale Z, which is this. Aha. Alright, okay. So the problem is that the center of the scale is actually based on the center of the original surface. I want to base off the center of the point that's been moved. I think what I'll do is that I'm gonna reverse this. I'm gonna scale the original surface first. I'm gonna scale this first, and then I'm gonna move it. I'm gonna scale this first, and then I'm gonna move it using the move to component. So point A to move from, which is the center of this, and point B to move to is going to be the center. Point B to move will be this. That's right. Yeah. Okay. So this is what we will have in the end. Sorry for the confusion. So just to explain, we want to scale this B wrap first. Do the scaling, and after we scale, we will do the moving based on the slider. Okay. So after the moving, we need to start moving outwards. So I will do a move component. We will move it outside of the window. So we just do a very basic move component. We need amplitude. Vector will be x-axis, and the amplitude, let's say we want to move it out by 500, for example. I'm talking about millimeters. And then it'll come out by 500 mil, which is fine. That is what I expected. I'll hide this for now. And then that's it. And then I will do a quick loft. I have to merge it down. So I have to merge fillet curve and this one here. So I can merge it together to generate a surface. But currently you can see, because it's merging together, it's actually trying to loft all 6 surfaces here. So what we need to do, we need to graph this individually so that 2 surfaces can sit together in a list. So this is great, but I want to add in the orientation of the window, the look towards the left. So I want to create some angle here. So I'm going to grab all this stuff, move to the right. I need to add in a rotation component. Rotate object around the axis, which is fine. Let's grab that. So I want to rotate this geometry. Angle will be in radians. So you gotta convert from degree to radian. Let's say I want to move this by 20 degrees. We will see how this will look like. And then the axis will be based on the z-axis. So currently Grasshopper doesn't know where is the center of rotation. That's why it's freaking out. Z-axis. Yeah. Z-axis. Z-axis. Okay. Maybe we have to do a rotate 3D component. A rotate 3D component. This will be a better tool because there's a center of rotation that we can assign. So do the same thing as well. Geometry and then radian. I will do 20 degrees for now. Center of rotation will be this. So I'm gonna put in an area to get the center of rotation here, and the centroid will be my center, and then the axis we can just leave it like this for now. Currently it's set to z-axis. When it says 001, the last number is the z-axis because it starts from x, y, z. So that is fine, we will leave it like this. So you can see now it's being rotated. So if I change this angle, it's going to rotate. But I want to rotate towards the left. I want to face this towards the left. So I'll double click this number slider. I'll just press in -100 so I can go into the negative, and it's angled towards the left. So what I have to do here is just changing this to this merge so that it's being lofted. So it will loft towards the angle orientation. That is good. So this is looking really good. I'll probably just group this up together so that we will remember the steps. So this is the move segment. This is the slider, and this one is the rotation. So I'll group up into 3 different steps here. 4 actually. So the first step here is, so I'm gonna label this into scribble. I will label this to say this one is for scaling. So remember, we can scale this based on what is the aperture width and height of the window. The next one here, we can orientation. I just say orientation of the window. The next one here is the protrusion, how much the window comes out. And the last one here is is the rotation of the window, so the angle. Okay. Nice. I'll just hide all this so we can only see the loft. So that is good, and let's probably do the same thing, but we will do the same type of window but looking towards the right, and everything will be almost the same. We just have to change a couple of settings here. So we need to assign some windows that look to the right for now. So let's say I will do 19, 5. I'm just choosing this randomly, there's no reason, there's no logic for now, and 7. So some windows are looking towards the right. I will change the orientation to look towards the right by changing this slider. So this can be interesting where they're both side by side. Protrusion, probably it's fine for now. I'll change the angle towards here, but maybe it's looking a bit too much. That's it. And then this one can be a little bit skinnier, the aperture. That's it. Very easy. So we have already set this script up, and we can just copy. We can just keep copying down. And this one we can say we want to look up. Some windows are looking up towards the sky. And let's start assigning what kind of window is looking up. So we can do number 12, number 6, number 20, all the top windows. Maybe number 15, for example. So these are the windows looking up. Aperture, we can set it to be wider so we can get more sunlight. Orientation, we want to look up. And then protrusion is fine. Now the angle, we need to change the angle a little bit because currently it's only rotating on the Z axis. We want to rotate on the Y axis. So we need to change, go to right click, so currently you see by default the axis of rotation has no value, so I need to put in the Y direction, unit Y, as the vector. So now the window will be looking up like this. And then I'm gonna make the window to be smaller just a little bit by changing the scale and the width. So these windows are looking up. Maybe I do something that is just a little bit more realistic, to make this a bit wider. So it's still a window in the end. You still want to look out onto the streets. Bring this down a little bit. Yeah, that's perfect. And then some windows can just be flat. And if it's flat, then it's gonna be just right at the center for the orientation. 0505 is the center, and I need to assign those flat windows. So maybe I can say 2, 11, 3, 18 will be the flat ones, and there won't be any angle, so I change this to 0. And that's it. And the last one will be, instead of flat, it's gonna be straight protrusion. so it'll come straight out. So it's gonna be the same with the flat one, but protrusion would be longer. And I need to assign the window for, let's say I do it for 0, 1, and that's it. Only these two large windows. So the 0 and 1 will have just a larger protrusion. Okay, very nice. And then 3, 13, 17, I'll just add into here. 3, 13, and 17. Probably add 3 here. And then the flat one can be 13 and 17. Okay. Probably save this file for now in case I lose it. Great. So I think we are almost done with this video. I can always merge it up together. Mesh all this loft surface together, and I will create a custom preview. And I will just do a color swatch, so I can create a customized color. For example, this can be I'll just do blue color, almost, yeah. And then I'll just hide the rest of it. So at this point, there's a lot of parameters that we can change. For example, if I don't like these two windows that are facing each other, I can change 8 to be facing left. So currently 8 is facing left. I can change left to be, instead of 8 it will be 5. And then for the right one, instead of 5, I can change this to 8, so it will look in a different direction. I can also change things like for the flat windows, I can make it really flat, like this. Okay. And then for this kind of windows that looks towards the right side, I can also change this parameter, the slider parameter, so that it will come in a little bit more. So there's a lot of adjustment can be made. Maybe this one is coming out a bit too much. So for the left one, which is the first one here, I can say the precision will be lesser. And that's it. Very straightforward. I hope you like this tutorial of this modular window style. Please like and subscribe, that will help me a lot. And if you have any questions, please leave down in the comment below. Thank you.